In this video, we're going to talk about yield calculations. In the lab, we don't usually have perfect reactions. Some reactant particles may just not get converted into product. Sometimes we also lose product when we're trying to recover it, such as when we try to do a filtration. We can predict how much product can get made, but usually we actually collect less than what we expect to. That's why we calculate yield as a percentage of what we expected to collect. So this equation looks like this. The percent yield is 100% times the amount of product collected divided by the theoretical amount of product. So the amount of product collected is the mass of product that we actually collected in the experiment, whereas the theoretical amount of product is the maximum mass of product that we could have made. And this is something that we determine using stoichiometry. So let's look at an example. In this one, a student reacts 20 grams of NaOH with an excess of HCl according to the balanced equation shown below. The student collects 21.3 grams of NaCl, and we want to know what is the percent yield of the reaction. And then we're given the molecular weight of NaOH and the molecular weight of NaCl. So what we need to know in order to calculate the percent yield is the actual amount of product that we collected and also the theoretical amount of product that we could have made. So let's work on calculating that theoretical amount of NaCl that we could have made. The maximum moles of NaCl produced would be the same as the moles of NaOH consumed. This is because they have a 1-to-1 molar ratio in the chemical equation. And remember, whenever we're doing stoichiometry, we need to be working in moles instead of by mass. So this will look like the mass of NaOH divided by the molecular weight of NaOH. We were given the mass of NaOH in the question, and we were also given the molecular weight of NaOH in the question. So let's go ahead and calculate what those moles consumed of NaOH would be. So 20 grams of NaOH divided by 40 grams per mole of NaOH gives us 0.5 moles of NaOH consumed. And this is also the number of moles of NaCl produced based on that 1-to-1 molar ratio. So the maximum moles of NaCl produced is 0.500 moles. We need to convert this into a mass so that we can compare it to the mass actually collected to calculate the yield. So the maximum mass of NaCl produced is the moles of NaCl times the molecular weight of NaCl. The moles we already found out, and the molecular weight is given in the question. So the 0.5 moles times the 58.44 grams per mole gives us a mass of 29.22 grams. Now it's time for us to actually calculate the yield. The theoretical amount of NaCl that we could make is the number we just calculated, 29.22 grams. So let's recall our yield formula. The amount of product collected divided by the theoretical amount of product. The theoretical amount we have, and the amount of product collected was given in the question. So let's plug those numbers in. 23.1 grams divided by 29.22 grams. This gives us a percent yield of 79.1%. Remember, percent yields should always be less than 100%. Whenever we put reactants together to form a product, we can either make up to the maximum amount of product that we expect based on the stoichiometry, or we can end up making less than that amount because of loss of product in some part of the reaction. So if you ever calculate a percent yield over 100%, you may have ended up swapping the positions of the theoretical amount and the actual amount collected.